Hi everyone, and thanks for taking the time to learn something you like. My name is Rafat Simreen, a cloud solutions architect, working on Microsoft infrastructure and cloud solutions. Since its inception in 2012, cloud computing and related solutions have become more intelligent and innovative. Therefore, I have shifted my focus and learning to Microsoft Azure and Office 365. I design, deploy, and manage cloud solutions for enterprise customers in Australia and globally. I'm also passionate about training and teaching. I train people on Azure Compute, storage, networking, security, app services, load balancers, gateways, and more. I also help customers learn Exchange Online, Teams, SharePoint Online, and OneDrive for Business. One of my favorites is Azure AD and the cloud's identity and access management projects. I love the stuff and I'm super excited about Microsoft's intro. I'm happy to take you on this learning journey. I will go into deep technical details and share useful resource materials that benefit you. In addition, I will answer all your technical questions and consider your feedback. I'm also happy to connect with you on LinkedIn for future assistance if that helps. Thanks again and enjoy the course. The Azure Storage Platform is Microsoft's cloud storage solution for modern data storage scenarios. Azure Storage offers highly available, massively scalable, durable, and secure storage for a variety of data objects in the cloud. Azure Storage data objects are accessible from anywhere in the world over HTTP or HTTPS via REST API. Azure Storage offers client libraries for developers building applications or services with .NET, Java, Python, JavaScript, C++, and Go. Now, developers and IT pros can use Azure PowerShell and Azure CLI to write scripts for data management and configuration tasks. Azure Portal and Azure Storage Explorer provide user interface tools for interacting with Azure Storage. Now, looking at the data services we can host in an Azure Storage, we have blobs, Azure Files, Azure Queues, Tables, and Disks. Looking at the blobs, now the blobs are the definition of Azure blobs. It's a massively scalable object store for text and binary data. Now this is unstructured data, Azure blobs. It also includes support for big data analytics through Data Lake Storage Gen 2. Looking at the files, they are managed file shares for cloud and on-prem deployments. The queues are messaging store for reliable messaging between application components. The tables are a NoSQL store for schemaless storage of structured data. So looking at the tables, they are structured data. Looking at the blobs, they are unstructured data. And finally, we have the disks, Azure disks. They are block level storage volumes for Azure VMs. So we use the disks in Azure VMs. These are Azure disks that are managed by Azure. So these are the 5 data services that we have or we host in Azure Storage. Once we create the storage account, we can host these data services. And we'll look at each one of them. We'll explain each one of them. The focus for this course is going to be on the blobs and files. We're going to be creating the storage account and using the blobs and files. We're going to run demos and build projects around those blobs and files. With queues, tables, and disks, we'll explain what they are and we'll explain some of the properties and options that we have with them. But the focus of this course, and probably the majority of customers use the blobs and files to store data in Azure. So the focus will be on Azure blobs and files for this course. Welcome back. Let's take a look at Azure Blob Storage. Actually, in this segment, I'm going to talk about Azure Blob Storage, files, tables, and queues. We're going to go into some details on each one of those data services before I get to the storage account where we can host these services and start creating the account and uploading files and all of that. So first, I'll start with the blob storage. Actually, the word blob comes from binary large object. So the full word is binary large object and the short form is blob. So blob storage, which is objects. So basically objects and storing objects in the cloud. So the definition of Azure Blob Storage is object storage, cloud optimized solution for storing massive amounts of unstructured data, such as text, binary data, and files, and all of that. So with the Azure Blob Storage, we can store text files, binary, we can logs, images, VHD files. So we can do all of that. And the use cases, we can serve images or documents directly to a browser. We can store files for distributed access. We can stream audio and video. We can write log files. So basically storing anything and everything that's files and objects in Azure. Now we access those files once we store them using HTTP or HTTPS from anywhere in the world. Once we have them there, we have the URL. So each object, each file, each image gets a URL. And this is part of, we're going to talk about the endpoints, but basically it gets that. And through HTTP and HTTPS or RESTful APIs, we can connect to them and get the data and access it that way. Now, objects in blob storage are accessible via Azure Storage REST API, PowerShell, CLI, or we can look at applications such as .NET, Java, Node.js, which is JavaScript, Python, Go, PHP, and Ruby. So if we are doing some development, we have some connectors, we have some connections, we can get to the data using REST APIs, and we can get to the data via HTTP and HTTPS. Looking at containers and blobs. So when we create a storage account, we can go ahead and create containers. Now containers, think of them as a file, a directory on a file system. So when we create folders or directories in a file system, similar sort of concept or analogy for containers. A storage account can include an unlimited number of containers, and a container can store or host unlimited number of blobs. If I look at this URL, which is HTTPS and then my account, now this my account is the name of my storage account. So it has to be unique. It's a unique namespace in Azure. So my account is the storage account name .blob.core.windows.net. Now this is important. So we have blob.core.windows.net. This is the fully qualified domain name, the namespace for blobs. Now replace blob with files, it's going to be for the files or Azure files. Replace that with tables, replace that with queues. So this is the fully qualified domain name or namespace for those data services in Azure. So basically the first one is the name of your storage account, .blob.core.windows.net for blobs, .files.core.windows.net for Azure files, .tables, .queues, and that's what we have. These are the namespaces we have in Azure for the different data services. So if I have a container called my container and container, I want to access that. So it's going to be HTTPS :// my account .blob.core.windows.net / my container. Now, if I look at, again, just talking about the URLs, look at the ones that we have below. So HTTPS my account .blob.core.windows.net and then / my container, that's the name of my container. My blob is the name of the blob or the file that I have in there. Same thing if I look at the last one below. So my account .blob.core.windows.net and then I have my container and then I have another one. So that's another container underneath my container, which is my virtual directory, and then / my blob. So I have a container underneath a container, and then I have the file in there. Now types of blobs, we have 3 types of blobs. And we can have these in a standard account, and we have them in a primary account as well, storage account, I mean. So we have blobs, which is text and binary data. Blobs are made up of blocks of data that can be managed individually. So different files, different images, different binary data or text. Blobs can store up to about 190.7 terabyte. Now the storage account, the whole storage account can have up to 500 terabyte. In one storage account in Azure, we can have 500 terabytes of data. If I'm doing a blob, if I'm doing blobs, and then inside I have a container that has a block blobs, that's 190.7 terabyte. I have append blobs and page blobs. Append optimized for append operations, things like logging data from virtual machines. So logs and data that we need to, that requires append operations, that's called append blobs. And page is the last one, which can store up to, it's random access files, things like VHDs, so operating system disks, and we have data disks and virtual machines. It can be up to 8 terabyte in size. So page blobs store VHDs and can serve as or serve disks in virtual machines. So these are the three types of blobs. Now, when we create a storage account in Azure and you upload a blob, the default is the blob. If you are uploading a file or image or a text file and all of that, so that's the default. But you can choose to have this as a append if it's a log file, or you can do a page blob if it's a VHD. Now this is for the standard storage account, and the same thing for the premium storage account as well. So we have these three different types of blobs that Azure Storage supports. And the last one in the Azure blobs is the components, looking at the architecture. So on the left hand side I have the account, and then I have container, and then I have blob. So I create a storage account. Inside that I have different containers for blobs, and then I have my blobs. So in this example, I have an account called Sally, and then I have two containers, pictures and movies, and then I have my blobs. Now, if you look at those URLs, by now probably you're familiar with the full URL. So https://sally.blob.core.windows.net, and then pictures is my container, and then I have the blob, and the same thing for the other one, which is /movie/move1.avi. Jumping to Azure Files, it's a fully managed file shares in the cloud that are accessible via SMB, NFS, and Azure Files REST API. So think of Azure Files as your file server in the cloud. To end user, it's seamless. It's the same network drive, and they just see the folders and they, upload files, read files, delete files, remove files, as if they would if the file server is just sitting next to them. The only difference is this is on-prem and the other one is in the cloud. So internet connectivity, network connectivity is really key because that's going to impact performance. Other than that, it's a file server. You have your files, you have your shares in there. Some of the use cases you replace or supplement on-prem file servers. If you have a few, you can move them to Azure, or let's say you want to create a new one. Don't create it on-prem, just create it in Azure. Lift and shift apps, if you have your apps need file access, so you can just move the apps to the cloud and move the file servers there and do the connectivity. Shared app settings, dev test, debug. These are all the use cases. Now, access, how do you access them? Once you have the files once you have the file or the Azure files, you build the group and the file servers in the cloud. How do you access them? Remember, with the blob, we have HTTP, HTTPS, and the other client applications. With Azure files, we have, depending on the operating system. So we use SMB, which is server message block protocol for if you are doing it from Windows. You can do NFS from if you are on Linux and Mac OS. And you can, so SMB for Windows and NFS for Linux and Mac OS clients. Now, the other thing is you can Again, for performance, you can do Azure File Sync. It's a service that we have in Azure Files that syncs the files down to your on-prem for caching and speed and performance, which is in the next slide. So this Azure File Sync, let me get to the next slide. Yeah. So it enables centralizing your organization's file shares in Azure files while keeping the flexibility, performance, and compatibility of a Windows file server. So think of OneDrive. So your OneDrive is the cloud, but you sync that OneDrive or the files in OneDrive to your Windows Explorer, and you can work with Explorer and does the syncing and the caching. So with Azure Files, we have this sort of mechanism. So the master, if you look at, before I get to the use cases, if you look at the process, so Azure file shares are created in the storage account. They become the master copy of the shares, but then we can do the stuff on-prem and it syncs that in real time. So this is what it does, is Azure File Sync. So I have my Azure files in the cloud and I do the Azure File Sync service. I install that on a file server on-prem. Let's say I have another file server in another region instead of doing DFS and replication. So my master copy is in Azure, and then I have the file sync that syncs those files locally to my file server, so users can still access the file servers locally, and that's going to sync back to the cloud. Use cases: you maintain on-prem file share performance for frequently used files. Again, it's a caching mechanism. You migrate on-prem file shares to Azure files because of redundancy, because of durability, because of cloud access, because of everything. You move that to Azure files, but you still have the on-prem caching mechanism. Provides low latency multi-site access for file shares. Again, if you have multiple sites and you want users to access the files locally instead of deploying file servers and DFS and doing the synchronization between the file servers, you basically have the master copy in Azure, but you still sync to on-prem for quick and real-time access. Next in the list, we have Azure Queues. What are they? They are storage service for storing large number of messages. A queue message can be up to 64 Ks in size. A queue may contain millions of messages up to the total capacity limit of storage accounts. So a storage account can have millions of queues if I'm just creating that account for queues, so up to the total capacity or the limit of the storage account. So large number of messages, these are for applications, and the messaging of the application, 64 kilobits in size. Queues are commonly used to create a backlog of work to process asynchronously. It's not synchronous, asynchronously. And we authenticate the calls by HTTP or HTTPS. And this is the URL. So my account is the name of my account, .q.core.windows.net, and then images to download is the name of the queue. So I can access using HTTPS and it has to be authenticated. Next, looking at the components, I have my storage account, which is my account in this instance, and then I have the queue, images to download, images to resize. And if you look at the URLs, my account.q.core.windows.net, and then the name of the queue, images to download, and the other one, same, my account.q.core.windows.net - images to resize. Just to remember, we have the name of the account. In this case, it's my account dot. We have queue, we have tables, we have files, we have blob. So just replacing the second word with the name of the service: blobs, files, queue, and tables. That's how we get access to the queues once we have the messages in the Azure queues in Azure. Let's have a look at Azure Tables. Azure Table Storage stores large amounts of structured data. Now, if you recall, blob storage is unstructured data, unstructured files, right? Now, with Azure Tables, it's structured. This service is a NoSQL data store that accepts authenticated calls from inside and outside the Azure cloud. So authenticated calls from inside and outside, it's a NoSQL data store, structured data. That's key. Azure Tables are ideal for storing structured, not relational data. Use cases, we can store large amounts of terabytes of structured data capable of serving web scale applications. And we can store datasets that don't require complex joins because it's non-relational, foreign keys or stored procedures that can be denormalized for fast access. We can quickly query data using clustered index, and we can access data using OData protocol and link queue queries with WCF data service.NET libraries. So as you can see, it's all to do with tables, structured and non-relational databases, NoSQL data store, and we have the applications and the different authentication protocols to access those .NET libraries. Now, how do we access? We have the storage account.table.core.windows.net and then / the table itself. So just a note on the URL. So the name of the storage account .table.core.windows.net / table. If I look at the different components on the next slide, so yes, I have my storage account, which is here. In this case, we have Sally. And then I have table. These are my tables. We have customers, we have wine photos, and these are the entities. These are entities that I have in there. I use my apps to build those tables and have the data in them if I have the Azure tables. And then I have my URL to access the tables using .NET applications and the different languages that are supported by Azure Storage. Azure disks are block-level managed disks that are managed by Azure and used with Azure VMs, Windows VMs, and Linux VMs. Disk roles, 3 roles. We have OS disk, temporary disk, and data disk. OS disk is the one that we install the operating system files on. The maximum capacity is 2 terabyte. The temporary disk, or the D drive in Windows, it's a short-term storage that we have applications such as page file and swap files. We have those page files and swap files on D drive. This is 8 gig. If you are provisioning a Windows VM, it's 8 gigabyte of temporary disk storage. That's D drive. Data disks, we can add additional disks depending on the size of the VM and depending on the region as well sometimes. So you have, these are additional disks that you use to store data such as database applications, etc. The maximum capacity is 32 terabyte. Now disk types, and this is important, we have premium SSD, standard SSD, and we have standard HDD. We also have premium SSD, V2, and ultra disk. Now the first 3, premium SSD, standard SSD, and standard HDD, are available in all VMs, all regions, and probably all sizes. Premium and ultra are sort of like special use cases, high performance, throughput, and also regions and sizes. Looking at the next slide will explain the difference or the metrics between different data between disk types, Azure disk types. So we have ultra disk, premium SSD V2, premium SSD, standard SSD, and standard HDD. Now they all are SDD if you look at the type, except for the last one, which is HDD. Looking at the ultra disk, it's IO intensive workloads such as SAP HANA, top tier database such as SQL and Oracle, and other transaction heavy workloads, ultra disks. Looking at the second one, it's production and performance sensitive workloads. That's Consistently require low latency, high IOPS, and high throughput. That's the premium SSD V2. It's one of the new ones that Azure introduced in the last year. We have premium SSD, that's production and performance sensitive workloads. The standard, web servers, lightly used enterprise applications and dev test. And then the last one is the standard HDD, which is used for backup, non-critical, infrequent access. Looking at the disk size, the maximum disk size 64 terabyte for the ultra disk, 65 terabyte for the ultra disk, 65 terabyte for the premium SSD V2, and then we have 32 terabyte for the rest of them, premium SSD, standard SSD, and standard HDD. They max at 32 terabytes. Maximum throughput for the ultra disk 4000 MBs per second, 1200, 900, 750, and 500 for the last one. Maximum IOPS 160,000 we get for the ultra disks, 80,000 for the premium SSD V2, and then 20,000, 6,000, and 2,000 for the standard HDD. And then finally, can we use these disks, or which ones we can use for operating system, which is the C drive. Now we can't use ultra disk, we can't use the premium SSD V2. These are only used for data disks. So they are additional disks we add to the VMs if we need to. So these are data disks. Looking at Windows VM, if I want to look at the disk roles, I have C, D, and E. So C drive, which is 127 gigs by default on Windows VM. Now this is drive C, it's persistent. So if you reboot the VM, if you deallocate, if you, like in case of redeployment, maintenance, this is a persistent data. Now D drive is non-persistent, meaning if you, in the event of maintenance, redeployment and stuff, you will lose the data on D drive. D drive is 8 gigs. It's run and managed by Azure. We don't actually choose this disk. We don't do anything with the size. We can't do anything with it. It just comes with Windows VM and Linux VMs. So on Windows, it's D drive, it's 8 gig, it's non-persistent. So we just use it for things like swap file, page file, and Azure uses it for probably background operations, maintenance, and all of that. So if you reboot the machine, the data is still on D, that's no issues. If you reboot the machine safely, like if it doesn't crash. In the case of maintenance events, in the case of redeployment, you will lose the data on D drive. So it's non-persistent. And the last one, which is a data disk, this is customer defined letter. So the first one is C, the second one is D. The third one can be E, F, O, Z, whatever you choose. It's persistent. So rebooting the machine and maintenance and all of that, redeployment, reapplying, the data will be persistent on the data disk. Again, just to recap, we have C, D, and E. They all can be premium SSD, premium SSD, standard SSD, or standard HDD. They all can be any of these types. Now only data disks can be ultra disks and premium SSD V2. And the final note is that you always pay for the disk type, size, snapshots, outbound data transfer, and number of transactions. You pay for disk type, size, snapshots, outbound data transfer, and number of transactions. Welcome back. Let's now talk about Azure Storage Account. This is an account that contains all of your Azure storage data objects, including blobs, file shares, queues, tables, and disks. Now, this storage account provides a unique namespace for your Azure storage data that's accessible from anywhere in the world over HTTP or HTTPS. If you recall, when we looked at blobs, files, queues, and tables, we looked at the URL that allows you to access, that enables you to access those data services. So it was the myaccount.blob.core.windows.net or myaccount.file.core.windows.net, myaccount.queue.core.windows.net, or myaccount.tables.core.windows.net. table.core.windows.net. So these are your endpoints. These are the standard URLs we have in Azure Storage, and depending on the data service that you host in Azure, you get those URLs. So it's a unique namespace. It's a URL that's associated, that's built, that's created for your storage account, and depending on the service, we get those URLs or those unique namespaces for your data. Now, the data in your storage account is durable, and we'll talk about durability when we get to the redundancy options for the storage account. Highly available, secure, and massively scalable. Massively scalable, we can have up to 500 terabytes of data in a storage account. 500 terabytes of data in a storage account. Next, I want to look at the different storage account types. So we have standard general purpose V2, which is used for most scenarios. And in this, we can have blobs, queues, tables, and files. Now, blobs including data lake storage. So a standard general purpose V2 can have all of the supported storage service or the data services we have. Let's skip the redundancy options for now, because that's going to be the next lecture talking about redundancy options and the different scenarios we have. Now, the usage for the standard general purpose V2, it's a standard storage account type for blobs, file shares, queues, and tables, and it's recommended for most scenarios. Looking at the premium blobs, now this is only for blob storage, including data lake storage. So this is just for blobs. We can't have tables or queues or file shares in this one here. Now this is a premium storage account type for block blobs and append blobs. If you recall, when we explained the blobs we have in Azure, we talked about blocks, we talked about append and page blobs. Block blobs are used for text, binary, files, images. Append are used for transaction logs, and page blobs are used for VHDs. So the first one here, premium block blobs, this is for block blobs and append blobs only. So this one is only for blobs, and it's recommended for scenarios with high transaction rates, or that use smaller objects or require consistently low storage latency. So high transaction rates, smaller objects, consistently low storage latency. So this is why we use this type of storage account. The second one, or the third one, is premium file shares. This is only Azure files. Now, if you look at this one, we can use Azure files here, and we can use Azure files here, and we have this premium file share for Azure files as well. What's the difference? This one here, we use it for SMB only. So you use the standard general purpose 2. If you want to use Azure files, you can only use SMB here. If you want to use NFS, you need to use this one. So with Azure files, as you know, with Azure files, we support Azure files from Windows and from Linux operating systems. Windows uses SMB protocol to get to the files. Linux uses NFS. If you want just to use Azure files for Windows, which is SMB, you just use it from here. You create the storage account with a standard general purpose V2, and you create your Azure files from here, and that's how you use it. You need to use NFS and plus other enterprise high performance scale application. Then you need to create a premium file shares, and the type is premium file shares that's going to use Azure files NFS here. And the last one is the premium page blocks, and this is only for page blobs only, which is VHDs. So if you want to create a premium page blobs storage account, that's going to be used for VHDs, Azure disks. So quickly, just to recap, standard general purpose V2, most scenarios, it does all the services. Premiums, we have 3 premiums. We have premium block blobs that does block blobs and append blobs, so it's only for blob storage. And then we have premium file share that does Azure files, and it only supports NFS and SMB. It does SMB as well, but the main thing here is NFS. And then we have premium page blobs that supports page blobs, which is Azure disks and VHDs. Jumping to the access tiers, we have 3 tiers in Azure Storage account. So we have hot, cool, and archive. Let's take a look at each one of those. So hot tier is an online tier optimized for storing data that's accessed or modified frequently. So it's online tier, the data is accessed or modified frequently. Now the hot tier has the highest storage cost, but the lowest access cost. So we pay for two things. We have storage cost, we have access cost. With the hot tier, the storage cost is high, but the access cost is low. The second one is the cool tier. It's an online tier optimized for storing data that's infrequently accessed or modified. It's an online tier, but the data is accessed infrequently. Now, data in the cool tier should be stored for a minimum of 30 days. So it's 30 days before we can access the data. Can we access before 30 days? Yes, but we'll get penalized. Microsoft will charge you for that. So it has to be stored for 30 days with no access, or the first 30 days. Now the cool tier has lower storage cost. So this is high storage cost. This is the lower storage cost, but higher access cost compared to the hot tier. So the difference between the two, this is online, this is frequent, infrequent. But two things: data has to be stored for a minimum of 30 days before you can access it, otherwise you'll get penalized. But then if you do access, like within the 30 days or after the 30 days, the cool tier has lower storage cost, but higher access cost. So you can't just store the data in the cool tier and then start accessing it like on a daily basis. You'll get charged more for the access cost. And access is read, write, copy, modify, and all of that. Now the last one, the third one, is archive tier. Now this is an offline tier optimized for storing rarely accessed data and flexible latency requirements. So rarely accessed. You don't need to access it on a weekly or monthly, maybe 6 months, a year, 2 years. It's archive. Now this is offline. The meaning of offline that the data is not there. You need to rehydrate the data before you can access it. So you go to the archive tier, you request the data, and then in a matter of hours, like probably 2 hours, 3 hours, 10 hours, I think 24 hours, the maximum Microsoft says 24 hours in their documentation, you're going to get the data. So it's as if it's stored somewhere. Think of it as stored somewhere, and they need to go and get the data. And then you can copy the data to the cool tier or hot tier to access it. Now, data in the archive tier should be stored for a minimum of 180 days. So that's 6 months. So you store or you save the data in an archive tier, and you cannot access it before 6 months. Now, if you do, again, you're going to get penalized for accessing the data before 180 days. So in a nutshell, hot is an online, cool is an online, archive is an offline. Now, this is optimized for frequently accessed, this is infrequently accessed, this is rarely accessed. And then we have this one, this has the highest storage cost, but lowest access cost. This one has lower storage cost, but higher access cost. And this one has the lowest storage cost actually. But again, with the access, you need to be careful. If you do it on infrequent and rehydration and stuff, this is fine. If you do it before 180 days, you're gonna get penalized. So again, to recap this whole lecture, so the storage account is a unique namespace in Azure that hosts all of your data services. We have 4 types of storage accounts. We have standard general purpose V2, that's used for most scenarios. We have premium, or 3 premiums. We have premium as in block blobs. We have premium page blobs, and we have premium for Azure files. The block blobs is for blocks and append blobs. Azure files is for Azure files. That's optimized for enterprise scale and NFS access requirements. And we have the page blob, which is for VHDs. Access tiers, we have hot, cool, and archive. Hot and cool are online tiers. The difference is that this is accessed frequently, the other one is accessed infrequently, and then we have the archive, which is offline. The data in the cool tier has to be stored for 30 days before we can access it. The data in the archive tier has to be stored for 180 days before we can access it. One of the key concepts in Azure Storage is the Azure Storage redundancy and the options I have with the storage account. So I have 4 options. The first one is locally redundant storage, LRS. The second one is zone redundant storage, ZRS. The third one is geo redundant storage, GRS. And the fourth one is geo zone redundant storage, GZRS. Now, these are important, or this key concept is important because it impacts the storage durability. So with locally redundant storage, it replicates your storage account 3 times within a single data center in the primary region. If I look at the second one, the zone redundant storage, it does that across zones in the same primary region. So there is a price difference in there. So I copy the files 3 times to one availability zone, or let's think of it as a physical data center. And in the second option, I do this across 3 data centers, 3 availability zones. So there is a price difference in there. So LRS replicates your storage account 3 times within a single data center in the primary region. The second one, zone redundant storage, does the same thing, but across zones, or 3 different zones in the primary region. When I look at geo-redundant storage, it copies your data synchronously 3 times. So it does 2 copies. The first one, it copies your data synchronously 3 times within a single physical location in the primary region using LRS. And then it copies your data asynchronously to a single physical location in the secondary region. Now within the secondary region, it copies your data synchronously 3 times using LRS. And the final one, the last one, is GU Zone Redundant Storage, GZRS. It copies your data synchronously across 3 Azure availability zones in the primary region using ZRS, and then copies your data asynchronously to a single physical location in the secondary region. Now within the secondary region, it does this using LRS, which is synchronous copying of your data 3 times using LRS. Now to explain all of these and to have some visual to understand what really happens, I have this Visio file that explains it. So I have here LRS, ZRS, GRS, GZRS. So let's start with locally redundant storage, LRS. So this is my primary region. This is my secondary region. In any geography, you will have 2 regions. These are called paired regions. So if this was West US, then this is East US. These are the paired regions in the States. If this was Australia East, then this is Australia Southeast. Or let's say this is UK West, this is UK South. So we have paired Azure regions in any geography or location. So this is my primary region. This is my secondary region. When I create a storage account, I have to pick a resource group, and that's tied to a location and all of that. So let's think of this as this is West US, this is East US, right? So this is my primary region, this is my secondary region. With LRS, what it does when you upload a file, let's just take the example of a blob file. So this is the text file or an image, a binary file, that when you upload a file to your storage account, to your blob container using LRS, what it does, it copies this file, it saves this file 3 times in one data center or one availability zone, right? Now each region has at least 3 availability zones. We have zone 1, zone 2, zone 3, and in the second region we have zone 1, zone 2, and zone 3. So with LRS, if I choose LRS, it does 3 copies in one zone. Now this gives me, now the write is synchronous. Synchronous means it does them, it writes them, copies them at the same time. And I won't get this green tick that the copy or the upload has been successful before it writes 3 copies. So once it does all of them at the same time, I get the green tick. So it's synchronous. Now this gives me 11 nines of durability. Durability is how well is your data protected from loss or corruption. This is, with storage accounts, we look at durability. So I get 11 nines, which is 99 point, and then I have 9 nines. So 11 nines means that even with 1 billion objects, so I have 1 billion objects, you would likely go 100 years without losing a single one. So 11 nines means if I have 1 billion objects, you would likely go 100 years without losing a single one file. So this is the meaning of 11 nines. Now this protects me, LRS protects me against drive and server rack failures, because this availability zone shares, like a drive in a server in a rack, and then I have the server rack. So if I have LRS, I'm basically protecting my data in Azure Storage against drive and server rack failures. So this is LRS. When I go to the second one, ZRS, which is zone redundant, what it does, it copies the files in 3 different zones in the same primary region. I'm still in the same primary region. This is zone redundant storage. So my first one goes to AZ1, second one goes to AZ2, third one goes to AZ3. Again, just for simplicity, let's think of these as data centers. So data center or physical data center 1, 2, and 3. So I still have 3 copies. This is the DRS. It does them synchronously, which is it writes them at the same time, right? I don't get the green tick, the successful upload or write or edit before it writes 3 copies in the same primary region. This is 12 nines. And again, I'm protecting my blobs or my storage against data center failure. So if this goes down, I still have 2 copies. This goes down, I still have 1 copy. Now the other one was against server rack and drive failures because it was in one physical data center availability zone. This one I have 3 zones. So if I lose a data center, I still have 2 other data centers. So I'm protecting myself against a data center failures. So this is called zone redundant storage. Let me go to the third one. Now this is called GRS, which is geo redundant storage. So we start now going to the second region. This is geo replication between primary and secondary. Now what it does here, it does LRS here and LRS here. So basically it copies or it writes synchronous in the primary region, asynchronous in the secondary region. So what it does, it copies the files, it writes the files to one availability zone in the primary region. So one zone, one zone, and we have 3 copies. And then, so this is synchronous, this is at the same time. And then it does, this is asynchronous, right? It writes them to the secondary region using one zone only, right? And this is asynchronous. Now this is 16 nines. The first one was 11, second one was 12, this is now 16. Now this protects my data against regional disaster. So if I have a problem in this whole region, in this whole geography, then I do have my data in the secondary region. So I'm protecting my data, my storage account against regional disaster. If I lose a region, a full region, then I still have my data, right? So this is called geo redundant storage, GRS. Then the last one I have here is called geo zone redundant storage, which is GZRS. Again, 3 copies in the primary data center or primary region, sorry. And then it does geo-replication and copies these to one zone in the secondary region. Now, the difference between this GZRS and the other one GRS is that here it does 3 copies or copies 3 files or saves 3 copies in the same zone, right? In this one here, it does them across zones, the 3 zones. So this is my zone 1, zone 2, zone 3. This is in the primary region. This is synchronous, asynchronous, and then it goes here. And this is in one zone in the secondary region. So synchronous in the primary region, asynchronous in the secondary region. Again, 16 nines, region and disaster. So it's the same here. The only difference is between GRS and GZRS is the primary region. In GRS, it does them in one zone. In this one, does them in 3 zones. Now, again, just to go back and to understand quickly, just to recap, we have 3 copies in one zone in the primary region. This is LRS. ZRS, 3 copies in the primary region across 3 zones. GRS, I have 3 copies and 3 copies, that's 6 copies. This one is in the primary region and this one is in the secondary region. This is LRS, this is LRS. Same thing here, I have 6 copies. In the primary region, I have 3. In the secondary region, I have 3. This is ZRS because it does them across zones. This is one zone, which is LRS, and I have my geo replication. If you have noticed, looking at all of them, so there are some takeaways from here just to understand what really happens or just to understand the overall picture. So it's always 3 copies in the primary region. So if I look at LRS, I have 3 copies in the primary region. If I look at ZRS, I have 3 copies in the primary region. If I look at GRS, I have 3 copies in the primary region. If I look at GZRS, I have 3 copies in the primary region. So it's always, or at least we have in any of those 4 options, I have 3 copies in the primary region. Now it's always 3 copies in the secondary region as well. And this is only when we look at geo. So with LRS, I have nothing. With ZRS, I have nothing. Now, this is the second region. If I look at GRS, I have 3 copies in the second region. If I look at GZRS, I have 3 copies in the secondary region. So across the 4 options, I have 3 copies in the primary region. If I look at the geo option, which is GRS and GZRS, I have 3 copies in the second region as well on top. So it's always the third note here, it's always LRS in the secondary region. So if I look at this, I have here LRS. If I look at this one, I have LRS. I don't have ZRS in the secondary region. In the primary region, I have LRS here, I have ZRS here, I have LRS here, I have ZRS here. Now looking at the secondary region, I have LRS. Looking at this one here, I have LRS. So it's always LRS in the secondary region. And also the final note here, it's always synchronous in the primary region. It's always asynchronous in the secondary region. So here, if I look at LRS, this is synchronous, 3 copies at the same time. If I look at ZRS, again, this is synchronous in the primary region. When I start going to the secondary region, now this is synchronous and this is asynchronous. When I look at this one, this is synchronous, this is asynchronous. So I can say that it's always synchronous in the primary region, it's always asynchronous in the secondary region. Welcome back. In this session, I want to talk about read access to the secondary region. And I want to link this to design principles that we use when we look at the best Azure redundancy option that meets your business requirements. First one, we need to consider the trade-off between pricing and availability requirements. So that's the first option. If I look at LRS, this is the lowest cost that I pay and the lowest availability for my storage account. So we have 3 copies of your storage account in one zone in the primary region, and this protects me against hardware failure, so drive and server rack. When I go to ZRS, I have 3 copies of my storage account in the primary region. Now this is across zones in the primary region, and this protects me against data center failure. When I move to GRS and GZRS, I have my data in a secondary region. As I move from LRS to ZRS to GRS to GZRS, prices and availability go up. So that's the first thing, a trade-off between pricing and availability. The second principle is, do I need availability or do I need to copy my storage account to the secondary region? One of the key factors there is compliance and data sovereignty. The distance between your primary and secondary region could be hundreds of miles. Now, in some cases, although few, this could be in another geography. So you need to consider that should you replicate or copy your data to the secondary region. And again, as we talked about paired regions in the first lecture of Azure Storage Redundancy, you need to look at those paired regions. Now, the third one, which I want to talk about, and this is linked to read access to the secondary region. If I go to LRS, it's obvious that I read and write to the primary region to this zone. When I move to ZRS, I still read and write my data to the primary region, which is across zones. Now, when I move to GRS, I have 3 copies of my storage account in the secondary region. And when I go to the GZRS, same thing, I have 3 copies of my storage account in one of the zones in the secondary region. Now, with GRS, I still read and write to my primary region. With GZRS, I still read and write to these zones in my primary region. One of the things you can do, you can read from this region if you want to, and you can read in GZRS, you can still read to this secondary region if you want to. Now, this is called read access, GRS, or RA-GRS. And in the second one, when you go to GZRS and you customize your application, you write your application to read from the secondary region, we call this RA-GZRS. So read access and then GRS, read access, and then GZRS. Now, this gives you more availability for your storage account. So you are still reading and writing to the primary region, but you have added read access to the secondary region. You can read and write to the primary region, and you've added read access to the secondary region. Now, if I look at some of the
parameters of durability and availability. These are the parameters. This is LRS, ZRS, GRS, and RAGRS. Now, GZRS and RAGZRS. Looking at durability, we talked about this. So we have 11 nines, 12 nines, 16 nines, 16 nines. Now, availability for read requests. So with LRS, at least 99.9%. Now, it's 99.9% for hot tier, and we have 99% for cool or archive access tiers. And I have this table I'll get to in a second that talks about 3 nines and 4 nines. Now, read request availability for read request with ZRS. So same thing, that's 3 nines, and we have 99% for cool or archive. Actually, if you look at all of those, it's the same. So we have 3 nines here, we have 3 nines here, we have 2 nines here, 2 nines here. It's the same. So availability and read access. It's always 3 nines for hot tier and 2 nines, 99% for cool and archive. Now, what happens here, if you look at when we do the read access, it goes up from 99.9 to 99.99. So 3 nines and 4 nines. And here it goes from 99% to 99.9 for cool and archive access tiers for RAGRS. And the same goes for RAGZRS. Looking at write requests with LRS, it's 3 nines and 99% for cool or archive. The same here and the same across the board. So we have 3 nines for write request, 3 nines for the hot tier, and we have 99% for cool and archive. Number of copies of data maintained on separate nodes. So we talked about this, 3 copies, because this is LRS. LRS, 3 copies in one zone. ZRS, we have 3 copies across in the primary region across 3 zones. Now with GRS and RAGRS, we have 6 copies, 3 and 3. And same thing goes here with GZRS, RAGZRS, we have 3 and 3. Now looking at this table here, the difference between 99.9 SLA and 99.99%, so 3 nines and 4 nines. What's the allowed downtime or unavailability? So with 99.9, it's 1 minute, 26 seconds a day, or you can read all these figures, but this is 1 minute, 26 seconds, or 8 hours, 45 minutes, and 56 seconds if you look at the yearly outage or unavailability of services. Now, this goes down from 1 minute, 26 seconds to 8 seconds if you look at the daily. If you look at the yearly, we have 8 hours, 45 minutes, 56 seconds. That's 52 minutes and 35 seconds. So adding just 1 9, bring this down from 8 hours, 45 minutes, 56 seconds to just less than an hour, which is 52 minutes. And you can look at other metrics as well. The other thing I want to look at supported redundancy options on storage services and storage account types. Now we looked at LRS, ZRS, GRS, RAGRS, and GZRS, RAGZRS. But the question is this supported across the board on all storage account types? Remember, we have 4 types of storage accounts. We have the first one, the standard, which is general purpose V2. We have the premium. The premium is 3. We have the block blobs, we have the page blobs, and we have Azure files for the premium storage accounts. So we have 4 storage accounts. And then with services, we have 4. We have the blobs, we have Azure files, we have tables and queues. So the question is, we have LRS, ZRS, and all of that. Are they supported across the board? And these 2 tables answer the question. So with LRS, we can do blob storage, including data lake storage, queues, Azure files, managed disks, and page blobs. With ZRS, we can do these. So if you look at blob storage is included in all of them. And we have here with GRS. So with ZRS, yes, we can do all of them. With GRS, we can't do, so we have the blobs, we have queues, tables, and the files. RA, we can't do files, for example. We can't read from the secondary region. So one of the limitations is that when you do RA, you can have read access to the secondary region if you have blobs, queues, and tables. So you can do your application, you can create or customize your application to read from the secondary region for blobs. So it can read blobs, it can read tables, it can read queues. It cannot read files, right? And this is what this says. So we don't have Azure files here, we don't have Azure files here. Now, blobs, queues, and tables are supported across the board for all redundancy options. If I look at the storage account types, so we have the standard general purpose V2 that's supported across the board. So that's supported in LRS, ZRS, GRS, RAGRS, and GZRS, RAGZRS. So it's supported across the board. Now again, with LRS, everything is supported. You can see that the premium blobs is here, and we have the Azure files here, and the premium page blocks are here. Looking at ZRS, I don't have the page. I have the files. I have the blocks. I don't have the page blobs. And then with the GRS and GZRS, I don't have any of the premium storage accounts. So it's really handy just to see how the redundancy options are supported on storage services and storage account types. Welcome back. Lucky last. We're going to talk about storage pricing, Azure Storage Pricing. When you come to this page, you can just look it up, Azure Storage Pricing. And the first thing we need to look at, or the first thing we need to probably select is the storage family. So we have the blobs, we have the data lake, we have managed disks, files, queues, page blobs, and tables. So I've selected blob storage. I can, let's say if I want to look at data lake, I can select this one. It will change the page and pricing and stuff to data lake. I can look at files if I want to. Azure files gives me that, but I want to go back to blobs because we are interested in the blobs at this stage. So let's have a look at this one. And I can go through overview, pricing table, some purchase options, resources, questions, and some of the stuff on the blobs. I'm fine with that one. Let's have a look now. The first thing I need to choose is my file structure. I have hierarchical namespace, NFS3 protocol. Now this is okay if I'm doing data lake, but I'm going to go for the flat namespace. And then redundancy options. I need to select my redundancy option. I'm going to stick with LRS for now. Australia East, that's my region. And then I have the currency. I'm going to do it in US dollars. I can pick any other currency if I want to. Now, these prices, it's really important to understand. Now, these prices is pay as you go. If you have enterprise agreement with Microsoft, your pricing will be different because you're going to have volume licensing and the prices will be lower than the ones that we see on this page. So first, 50 terabytes. How much do you pay per month? If this is premium, this is how much we're going to pay. So that's 218 of a dollar, which is 22 cents. But looking at hot, that's the standard. So it's 2 cents, 0.02 per gigabyte per month. And then for the cool, we have 0.011. And for the archive, we have 0.002 per gigabyte per month. That's the first 50 terabytes. The next 450, this is how much we pay. And if we have over 500 terabytes, this is how much we pay per gigabyte per month. The other option is you can do reserved capacity for the 100 terabytes per month. This is how much you end up paying. Hot, cool, and archive, this is how much you end up paying per month. And if you do a 3-year reserved capacity, this is how much you end up paying per month. So if you are going to, for example, archive 100 terabyte of data, this is how much you're going to pay per month. So you times this 168 times 12. If you are doing 1 year reserve, you times this by 36 if you are doing 3 years reserve. And this is going to be much cheaper than doing it this way. This is the next 450. It's going to be much cheaper than doing it this way. Now, cool and archive early deletion. If you recall with cool access tier, you have to store the data for 30 days before you can access it. If you are doing archive, that's 180 days before you can access it. So the question is, what happens if you delete the data? And I think it applies even if you want to access the data. What happens is you get charged. So it says here if you delete or move to the hot tier after 45 days, the customers charge an early deletion fee for 135. So that's 180 minus 45 days. So you're going to get charged if you remove stuff if you remove or move it to the hot tier from cool or archive. So that's another pricing factor you need to take into consideration. Now, operations and data transfer. So remember, with the pricing, we pay for two things. We pay for the storage, and we also pay for operations. So things like write operations. Now, this is per 10,000 write requests, or write operations. This is how much we pay for 10,000. So if you are doing 10,000 write operations a month on a hot tier blob, for example, then this is how much you're gonna pay. Cool, this is how much you're gonna pay, and then archive, this is how much you're gonna pay. Now, list and create container operations, again, for 10,000 read operations, and so on and so forth. So this is how much you pay per month for 10,000 operations, like read, write, edit. I think you don't pay anything for delete, if I recall correctly. There it is, but that's fine, that's okay. And then we have blob index. So blob index per 10K tags, this is how much we pay for hot, cool, and archive. Data transfer prices to block, that's fine. We pay nothing for LRS or ZRS. Once we move to the other region, this is how much we pay the second region. With other features, if you want to, the log for the changes, it's disabled by default. You want to enable that and get the logs, then this is how much you're going to get charged. And encryption, if you want to do encryption on the container or individual blob, this is how much you're going to get charged. If I look at quickly, I want to go through files. For example, let's have a look at Azure files. How much do we get charged? Again, LRS. I have those ones. Remember, with Azure files, we can't read from the secondary region. That's why we only have those 4 options. Again, Australia East, US dollars, that's fine. Data storage. So data at rest, this is how much I'm going to get charged. We have transaction optimized, hot, cool. These are the access tiers. If you want to choose this for the premium storage account, snapshots. If we are doing snapshots, this is how much we're going to get charged. And then metadata, that's included with the transaction optimized. And we are paying for the hot and cool tiers. So this is for, again, we can do reserve capacity for 1 year. We can do it for 3 years. 10 terabytes, 100 terabytes, this is how much we're going to pay a month. Transfer and data, transactions and data transfer. Again, we can go through these. File sync, if we are doing file sync, so per server, we are paying $5.50 a month. We can have multiple file servers. We can do multiple syncs, different regions if we need to. So you are paying $5.50 per server. So this is for Azure files. And the last one I want to look at quickly is the managed disks. Now, managed disks, we have premium SSD, we have standard SSD, and we have standard HDD. Now, how much do you pay for this? I want to take the example of a Windows VM, Windows Server VM. So the C drive is 127 gig by default. We can't change this. We can increase the size. We can't reduce the size. So let's have a look at that. LRS and GRS, I don't have G-redundant option. GRS and GZRS, I don't have these with managed disk. Australia East, and I have US dollar, that's the current. So premium SSD, let's have a look at this. The P10, which is 128 gig. So if I have a Windows VM, my C drive is 127 gigs. I'm paying $19.71. This is for the month. When you deallocate a Windows VM, you don't pay for compute, RAM, and network data and transfer because you're not doing anything, but you still pay for the storage, for the managed disk. So you are paying 19.71 for the month. Whether you're using the full 127 gigs, you're using 1 gig or 2 gigs, your VM is allocated or deallocated, you are paying 19.71. This is really important. Some people think that when you deallocate the VM, you don't pay for storage. Storage is the only component in Azure IaaS that you pay for the full month. Once you provision the disk, because this is managed disk. When I go to the second one, which is standard SSD, I'm talking about C drive, I'm talking about the OS drive. So we can select premium SSD, standard SSD, or standard HDD. We can't choose the ultra disk, we can't choose the premium V1. So standard SSD, and this is E, so this is E10 128, you are paying 13.06 cents a month. And the last one, the standard HDD, we're paying for S10. This is S10 9.43. So 19.7, 13.06, and 9.43. This is really important. If your VM is a production VM, probably you need to go for the premium SSD, $19.71 a month. If it's a lab, if it's a demo, VM, probably you can look at the standard SSD 13.06 or the standard HDD, which is 9.43. Now, these are the pricing tables for my storage account. And again, I can look at queues, I can look at tables, I can look at page blobs and stuff. The other one I want to look at is the pricing calculator. Now, this is really important. This is really good. One of the good resources that we have with Azure. So you can look at different services, but what's really important for us here is look at storage accounts. So once you select your storage account, then we can go to, we can look at, this is the storage account. Probably I selected some of the stuff here, don't worry about it. So once you select the storage account, same thing, you have your region, you have your storage type, you have your tier, you have your redundancy, and here I can look at capacity, write operations, read operations, and all of that. So basically, this is going to estimate how much it's going to cost me if I select any type or any tier of my Azure storage. Now, if I want to do like compute and, for example, storage, if I want to look at other services, basically this is a very helpful resource that looks at all parameters, all services, and gives me the right pricing or the right estimation for my services. This is one of the pricing examples. I worked on one of the projects a couple of months ago, and the customer has 8 terabytes of data they want to store in Azure blobs. So I got the pricing from the Azure pricing page we just looked at, and I looked at the different redundancy options and the prices, and I thought we're going to do some operations like 10,000 operations. This is read and write across the board, and then we're going to do the blob index, which is 10,000 tags, right? So I did the calculation here. So 8 terabyte of LRS data storage on the hot tier. So this is, they both are hot tier, but this is LRS and this is GRS. With 100K file operations a month. Now 100K is 10 times the 10K. So I thought let's do, so 10 times of write and 10 times of read, as in the context of pricing, of course. This would cost, this is 8,000 gigabytes into, this is 0.3, which is the 3 cents in the hot tier, LRS. And then I thought, yeah, we're going to do 10,000 operations. So this is 5,000 read and 5,000 writes. And then, so this is the 247 for the storage, and this is for the read operations. This is for the write operations. So $247.62 a month. I did the same thing, but with GRS, and this is 495. So you can see this is 247, 495 is just, we doubled the monthly pricing when we went from locally redundant storage to geo redundant storage. Let's recap on what we have learned so far. First of all, let's define what Azure Storage is. It's a cloud storage solution for modern data storage scenarios. It's highly available, massively scalable, durable, and secure storage for a variety of data objects in the cloud. Now, data objects can be accessed from anywhere in the world over HTTP or HTTPS. If I look at the data services I can host in Azure Storage, I have Azure blobs, files, queues, tables, and disks. And for that, I need Azure Storage account. I create Azure Storage account to host all these data services. A storage account is a unique namespace in Azure that holds all of your Azure Storage data objects. And let's have a look at those data services. The first one, for binary text and images, I use blobs. And to access these blobs, in Azure, I create my storage account. For example, I call it my account. So the URL for my blobs is going to be https://myaccount.blob.core.windows.net and then slash the name of my container slash the name of the blob. For file shares, Azure Files, the URL is going to be https://myaccount.file.core.windows.net message queues for queues. I'm going to have myaccount.queue.core.windows.net. And finally, tables, the NoSQL schema, structured data. I have Azure tables, and the URL is going to be myaccount.table.core.windows.net. When I look at the storage account types, I have 4 different types I can choose from when I create my storage account. Now, if I want to host blobs, files, queues, and tables, I use a standard general purpose v2. This is recommended from Microsoft for most scenarios. If I want to focus on premium storage accounts, and I start with the block blobs and append blobs, I'm going to choose premium block blobs. If I have PHPs, that's page blobs. I'm going to choose premium page blobs. And finally, for premium files, Azure Files, I'm going to use the premium file shares. And for access tiers, I have 3 access tiers. For the frequently accessed data, I need an online tier, that's hot tier. For infrequently accessed data, another online tier, that's cool tier. And for rarely accessed data, that's offline tier, it's an archive tier. The infrequently accessed data should not be accessed before 30 days. The archive tier should not be accessed before 180 days. Let's have a look at my redundancy options. And the first one, I copy my storage account 3 times into one of the zones in my primary region. The copying is synchronous, and this is called LRS, locally redundant storage. So 3 copies of my storage account in one zone in the primary region. And I get 11 nines durability, 11 nines durability. Looking at the second option, I copy my storage account 3 times to 3 different zones in my primary region. Zone 1, Zone 2, Zone 3. This copying is synchronous, and this is called ZRS, Zone Redundant Storage. 3 copies in 3 different zones in my primary region, ZRS, and this gives me 12 nines. Option number 3, I now have 6 copies of my storage account. So first, I copy my storage account into one of the zones 3 times. This is synchronous. And then I replicate to the secondary region, and I copy my storage account 3 times to one of the zones in the secondary region. Copying the storage accounts, the 3 copies of my storage account in the primary region is synchronous, but in the secondary region, it's asynchronous. And this is called GRS, Geo Redundant Storage, and I get 16 nines. The fourth option is copying my storage account into 3 zones in the primary region synchronously, and then geo-replicate to the secondary region to copy my storage account 3 times into one of the zones. So this is 3 times in 3 different zones in the primary region, synchronous, and then geo-replication to the secondary region, copying my storage account 3 times into one of the zones asynchronously, and this is called GZRS or Geo Zone Redundant Storage, and this gives me 16 nines.